Alrighty, so here we are with moving into actually doing rational expressions. So we've been practicing fractions, which is included in rational ratio expressions, and then we've also been doing factoring. So hopefully today we can simplify some rational expressions and then through this multiplying and dividing. Alright, so let's give it a try here. So here's some examples of rational expressions. It's a quotient of two polynomials. So for instance, here you see x squared minus 4, that's a polynomial, and then we've got x plus 2, that's a polynomial. So it can be quadratic, it can be cubic, it's whatever it is on top and bottom. Notice here that we have a constant, that's a polynomial, that's fine, one term. So these are all excellent examples of that. And then just a reminder that you can simplify fractions. So for instance, if you have 9, you can reduce that or factor that, put that in its factors of 3 and 3. And then 24 happens to be 8 and 3, and so because there are both 3's there, we've got 3/8. I mean, you could have also done what I usually do, which is divide by 3. Either way. Put them into the factors and cancel is what we're actually going to be using more when it comes to reducing rational functions. So, first thing here, we're going to do simplifying rational expressions that aren't necessarily, they're going to be monomials. So we've got monomials that we're simplifying. Then we'll go to polynomials. So identifying any x values for which the expression is undefined is an interesting moment, so we'll go over that as well. So taking a look at just the numbers here, we've got a 10 over 6. So if we're imagining that fraction, to reduce that fraction, I would divide by 2 to the top and bottom and get 5/3. Alright, if we imagine just the variable, we've got x to the 8th, x to the 4th, and to reduce those, you can divide out technically x to the 4th. So if we divide out x to the 4th, which is just a 1, you get x to the 4th over 1, or just x to the 4th. It's probably easier to put them back together if we imagine it as x to the 4th over 1, because now we have 5/3, and that's combined with x to the 4th over 1. And so combining those together, you get 5x to the 4th on top and 3 on bottom. And so this is our answer, our solution of simplified. Okay. Then they're asking you, okay, well, looking at this first part, what couldn't happen or can never happen in a denominator? And that's 0. And so when does, let's see, undefined. So when does that happen? It's when 6x to the 4th equals 0. So if we solve that by dividing by 6, well, it's still 0. And then if we take the 4th root, because that's going to undo a 4th power, it's still 0. So x cannot be 0. That's the undefined part, because otherwise you would have a denominator of 0, which we don't want in that original function. So that's your undefined piece. So basically you simplify, then you go back to the original equation and double check if there's something that makes it inappropriate, like a 0 on the bottom or a negative square root or something. So these next ones here, we're going to go ahead and simplify, but that means we're going to have to factor them. So a lot of people end up trying to factor or simplify by like crossing things out, but anytime that you have a plus or a minus going on, you can't just cancel from top to bottom. You do have to cancel an entire chunk of the same idea that's multiplied. So the first thing we're going to do is rewrite these as their factored versions. So you're trying to find what multiplies to be -2, but at the same time adds to be 1. So two numbers that multiply to be -2 and add to be 1 is going to be a +2 and a -1, because again those add to be 1. So that means our factors on top are going to be x plus 2 and x minus 1. On the bottom, again, we're trying to multiply to be this last number, so multiply to be -3, and then at the same time add to be 2. So the two numbers that multiply to be -3 but add to be 2 is going to be 3 and -1, because again those add to be 2. So as we simplify, let's see, our reduce, our factors are x plus 3 and x minus 1. And so hopefully you see that we can now cancel. So we can cancel this factor. Yes, there is multiplication and, adding and subtracting involved, but it's this whole unit that cancels with itself. So we have x plus 2 on top and x plus 3 on bottom, and that is our reduced simplified answer. Then, as we talked about before, when is it going to be undefined? Okay, and it's actually undefined at the opposite of your denominator. So the opposite of positive 3 would be negative 3, and then the opposite of negative 1 would be positive 1. So that's where it's undefined. And so again, that came from when will x plus 3 equal 0, and that's if we subtract 3 and get an x of negative 3. And then will x minus 1 equal 0, and that's if we add a 1 to both sides. And so those are the two pieces that make it undefined. All right. So moving on, we've got some more. I think this is when in class I would have just had you do these on your own, but the idea is the same. You're going to do your numbers first, then your letters first, and then of course look for undefined ideas. So if you want to pause the video, that's cool, because then you could try it on your own. Otherwise, 16/8 is actually 2, so that'll be in the answer. And it's technically 2 over 1, which is probably more helpful. And then we've got our numbers, which would be x to the 11th over x squared. And so if we take out x squared, just like we divided by 8 on this one, we're going to get x squared on top and 1 on bottom. So putting it all together, notice they're both over 1 anyway, so it's still just 2 over 1 times x squared over 1, and so our answer is just 2x squared. But of course, since we came from this original equation of 8x squared equal to 0, it's undefined at x equals 0, because that's the only way that you would get a 0 from 8x squared. So, again, x cannot be 0 because it would be undefined at 0, so that's what our answer includes. Alright, this next one here, if we factor, we can't actually factor the top, but hopefully we can factor the bottom, which is 3 times negative 4. 3 times negative 4 is negative 12, and we're trying to find the factors of negative 12 that add to be 1. So the factors of negative 12 that add to be positive 1 is actually 4 and negative 3, so interesting that it's the opposite of what we did to get there, because again those add to be 1. So rewriting our equation, the top is still 3x plus 4. And then actually I was taking it a step too fast. Those are now the pieces that would go into the box with an x. So we have, oops, that's not where it goes, 4x here and negative 3x here from our original equation of 3x squared plus 1x minus 4. And so to get our factors from that, we take our rows and columns and pull out the like pieces. So for instance, in this first column, there's a 3 and an x in both of those. In this column, there's a 4 in both. Over here, we've got an x in both. And then over here, we've got a negative 1. Then you just want to double check that you actually have it multiplying out to be the same thing, which we do here. Yep, that all works out. And so now our factors are 3x plus 4 and x minus 1, which of course goes with the numerator that used to be there, because we have a 3x plus 4 that we can cancel. So 3x plus 4's cancel, which means that we'll have a 1 on top and an x minus 1 on bottom, which usually we don't put the parentheses there for. Then what can't x be? It can't be any of the numbers on the bottom here that would have made 0. So when does 3x plus 4 equal 0? Well, if you subtract 4, divide by 3, you get an x of negative 1.3 repeating. Well, we'll just do negative 4/3. And then from the other one, when will x minus 1 equal 0? And that's just at adding of 1, so at 1. So that's part of the answer as well. Alright, so that's our next example. Then the interesting part here is taking a look at what your calculator allows you to do. So the calculator screen suggests for this problem here that if we took 4x minus x squared over x squared minus 2x minus 8 and reduced it, turns out this is its reduction or its simplification. We know from the original graph that if we had, because it factors into x plus 2x minus 4, because of that, we know that x equal to 4 and x equal to 2 won't work, and so you can see that in the equation. So since we put y1 as the original equation, you'll notice that they got an error at negative 2 and an error at 4, right? Because we said that it can't be negative 2 or 4 because of our, undefined areas. However, when you graph the second equation, which is the simplified version, you end up only with an error at negative 2, and that's because the simplified version only has x plus 2 in the denominator. It doesn't include 4, and so you can never actually just do the undefined terms based on your answer. You have to do undefined based on the original. So that's kind of what this is saying. Find undefined terms or values from the original function. Otherwise, you're going to probably miss one. Alright, so here we are with multiplying. So that was just reducing before, and now we're going to multiply. So you can multiply rational expressions the same way that you multiply fractions. So you're going to factor them. That's kind of part 1. Factor all the numerators and denominators, just so we can see what pieces we're looking at. Divide out any common factors, so that's your canceling. And then you can multiply the numerators, so you can kind of combine it together. And then part 4, you're going to be sure that the numerator and denominator have no common factors other than 1. Which just means double check your work. You never know if you missed kind of one of those alike pieces that would have canceled. Alright, so anytime that you're multiplying, you can go ahead and just make this into one big fraction, and then go ahead and actually combine terms. So if we were factoring first, which this one doesn't because it's monomials, we would go ahead and do that first. But because it's not, we can just multiply across and then end up reducing. So 3 times 10 will leave you with a 30 on top. X to the 5th and 3rd leaves you with 8 on top. Y to the 3rd and 4th makes a 7. And then in the denominator, you've got a 2 and a 9, which will multiply to be 18. X to the 3rd and x squared, which makes x to the 5th. And then a y to the 7th and a y to the 5th, which is going to make a y to the 12th. So now all you need to do is, again, kind of think of it in its pieces, but we're reducing 30/18. And so, let's see, 30/18 is going to be divided by 6. So if we divide by 6 to the top and the bottom, we're going to end up with 5/3. From your 8 to x to the 8, and your x to the 5th, you're going to end up having none on the bottom and then 3 left over on top, so x to the 3rd. And then if you have 7 on top of the y's and 12 on the bottom, if you cancel out 7 of them, you're left with 5. So 5 on the bottom. And so that is our reduction after multiplying. Notice that it says that you're going to assume that all expressions are defined, so you don't have to say anything like x can't be 0 or whatever it is. That in these ones is skipped because it's more about the solution that you get. Alright, so then we move on to one that actually is where you need to factor first. So again, I know the difference because this one here, notice there's absolutely no addition or subtraction going on versus this one there is. Sometimes it helps me a little bit when I put parentheses around everything, just because I understand that, for instance, x plus 3 is already factored, and so that's one of the pieces that could potentially cancel. So putting them all, factoring them all out, this top one here, if I divide everything by 10, I can take out a 10 and be left with x minus 4 on the top. In the bottom here, I'm trying to multiply to be 8 and add to be negative 6. And so negative 2 and negative 4 are those pieces, so x minus 2 and x minus 4 would be the factor of the denominator there. And then this last one, the only thing that comes out of both of them is a 5, and you're left with x and then 3. So rewriting this so that it does have all of the pieces now, you actually have 10, x minus 4, bottom, x minus 2, x minus 4. And then that's being multiplied by the x plus 3, and then the 5x plus 3. So making that all into one fraction that can cross divide or cross cancel, those two will cancel, those two will cancel, and without necessarily seeing it maybe, the 10 and the 5 can reduce as well. If you divide by 5 to both of these, you're going to end up with a 2 and a 1 on the bottom, but we don't really need a 1. Alright, then in the numerator, the only thing is a 2, and then in the denominator, the only thing we haven't canceled yet is the x minus 2. So the answer is just 2 over x minus 2, which I, of course, put kind of not in the center there. And so that's our reduction. Again, assuming that all expressions are defined, so we don't have to say that x can't be whatever the denominator used to be. Alright. So then, if we think about the next step, which would be division, all you need to do is change your division into multiplying, which takes, of course, another step as well, and then you'll be able to solve. So taking a look at this one, hopefully you remember whatever strategy it was that you learned, but keep, change, keep, switch, flip, whatever it was, you change this to multiplication, and then flip this fraction, and now it's going to be easier to solve. So officially, to change your division into multiplication, you keep the first one the same, change the sign to multiplication, and then flip the second one, and now you can just use multiplication instead of division. So in order to solve this, I'm going to make this into kind of it all together. So I'm going to multiply across and get 40 from 5 times 8. I'll have x to the 4th and y to the 5th. And then in the denominator, 8 times 15 results in 120. And then we have an x squared still and a y squared. Now is when we get to reduce. So again, think of it as the numbers, the x's and the y's. And so 40 over 120 can be reduced by 40. So if I divide by 40 to the top and the bottom, I get a 1 on top and a 3 on bottom. For the x's, there's 4 on top and 2 on bottom, so if we reduce, there's 2 left on top. And then for the y's, there's 5 on top and 2 on bottom, so if we reduce, there's 3 left over on top. So a little less sloppy, we've got x squared, y cubed, all of that over 3. Alright, so then we move on to division, but now it's with the factors. So we're going to take the time to keep, switch, flip, or keep, change, whatever it is, and then we can go ahead and start talking about factoring. So we really have x to the 4th minus 9x squared over x squared minus 4x plus 3 times the flip. So x squared minus 16 on top, x to the 4th plus 2x to the 3rd minus 8x squared on bottom. Alright, so factoring out our pieces, looking at this first one here, an x squared could be taken out of both of these, And so if you take an x squared out of the numerator in both of these, you end up with an x squared out front, and then x squared minus 9. Which ends up being a difference of squares, and so officially I can rewrite that top one as x squared, but then x minus 3 and x plus 3, because that would have become x squared minus 9. In the bottom one, we go back to a leading coefficient of 1, so we're just trying to multiply to be 3, but then at the same time add to be negative 4. And so the only numbers that do that are going to be an x minus 3 and an x minus 1. Moving along to our next one, it's also a difference of squares, and so it's going to be an x minus 4 for the 16 and x plus 4 to, again, make that 16. And then the last one, definitely have a bunch of x's in each of them. So if I take an x squared out front, I'm left with x squared plus 2x minus 8, which hopefully can change. So negative 8 is what we're trying to multiply to get. And then at the same time we're trying to add to get 2. So if we're going to multiply to get negative 8 and add to get positive 2, that's going to mean that one of our numbers is 4 and the other is negative 2. So in the end, we have an x squared still out front, but then that trinomial becomes x plus 4 and x minus 2. Alright, and so now we can start canceling. So now we can cancel, which is the fun part here. And so canceling, let's see. Oh, an x squared and an x squared, definitely. An x minus 3 and one other x minus 3. Plus 4 and a plus 4. Just be careful that they do actually match. And then all the rest of it is not canceling. So our end result is x plus 3, x minus 4. And then our denominator is x minus 1, x minus 2. Alright. So the next two are all about solving, which of course is a little bit different, but at the same time, hopefully you notice that this polynomial is being divided by this polynomial. So if it's being divided and I'm trying to solve, I actually am going to want to multiply both sides by x minus 2. It's a little easier if I can actually put it on the top, because then you can see that if I multiply by x minus 2, this x minus 2 and this one will cancel, and then this one will actually be able to be distributed. So officially on the left side, we're left with x squared plus 3x minus 10, and on the right side, we're left with 7x minus 14. So how do you solve something like this? Well, anytime there is a squared, basically you either get to factor, or you can use the quadratic equation. But you can't do that until you have moved all of the pieces so that it's actually equal to 0. So if I move a 7x over here, and if I move the 14 over here, I end up with x squared minus 4x plus 4. And I try to see if I can either factor that or end up using the quadratic equation with your a, b, and c. So let's see, I'm going to multiply to be positive 4 and add to be negative 4, and so that actually comes from x minus 2 and then x minus 2 again. So when will those two equal 0? Just at an x of 2. So we know that x equals 2. They are asking you to check your solution, so you can always go ahead and plug that back in. And usually when you're checking your solution, it's because of the undefined ideas. Because as much as I just said, oh, x equals 2, what happens when I put a 2 into this original equation? I get 0 on the bottom. So whatever the number is on top, I get a 0 on bottom, and so there's actually no solutions to this. So, kind of depressing, but also fine, because that's the answer. Alright? And so we'll do one more just like this. Again, the idea is that this is being divided by this number. or this factor, and so we can go ahead and multiply by that factor to both sides. Distribute, and we're going to end up with x squared plus x minus 12 equal to negative 7x minus 28. Just like the previous problem, we need it to equal 0, so we'll move our pieces over. So we'll end up with x squared, there's a 1 and a 7 to make 8x, and a negative 12 and a 28 to make 16. And so then I just have to see if I can actually factor this. So is there something that multiplies to be 16, but at the same time adds to be 8? And that's a 4 and a 4. So that means that x plus 4 and x plus 4 are somehow supposed to equal 0. So when will that make a 0? When you plug in a negative 4, right? So x is negative 4. Then you need to check your answer by plugging it back in. And if I plug in a negative 4 plus 4 makes 0, and 0 can't be on there. Again, checking your solution is looking for the undefined values. And so again, we get a number over 0 at negative 4, and so we don't actually have any solutions. Again. Sometimes there will be multiple values that could be your solutions, and so in that case maybe one or two of them will cancel, but then you will actually have numbers that work. So, just depends. Alright, so that is our 5-2 note. It's kind of big, but that's just because we were doing some practice to make sure it made sense.